Hey everyone, hope you're all doing great. As the title says, in this video we are going to cover the most important, difficult and common questions from Chemistry Unit 3, the ones that show up again and again in exams. So without further ado, let's begin. The first question says, it is suspected that a bottle of magnesium chloride solution has been contaminated with barium chloride. Describe a test and its result other than a flame test, which could be used to confirm that the bottle contains traces of barium chloride. Now we know this that basically if you want to test where other than a flame test, basically they're telling you to test the presence of sulfate ion here. So what you do is that you just add sulfuric acid, and if a white precipitate of barium sulfate gets produced, then we can ensure the presence of barium ions are there, considering barium chloride consists of barium ions. So if we can anyhow produce a compound which consists of barium, so we can ensure that the bottle contains traces of barium chloride. Now state the colors produced by magnesium and barium ions in a flame test. We know magnesium does not provide any color, while for barium it's green. Okay, moving on to the next part. Uh, Next question here, they say number 4, an experiment was carried out to compare the rates of hydrolysis of different halogenoalkanes, and the results were shown. The method and the results are basically here shown. You can clearly see. So they said here, justify an appropriate temperature uh, for the water bath, as we can clearly see out there. That how do you justify the appropriate temperature down here for the water bath? Now, it must be 50 degrees Celsius, because if you see here, the if you see basically because first of all it's 50 degrees Celsius because the solution needs to be warm, right? But it shouldn't be that warm, because if it's too high, it would make the liquid or organic liquid evaporate. So we need to basically choose an optimum temperature which won't allow to which will allow basically to make the solution go through a increased rate, and also at the same time it must not be that much high to to ensure that the organic liquid does not evaporate. Okay, moving on to the next one, number C, they said, state how the results of this experiment could be converted into a value that can be used as a measure of rate. Now, if we can find the reciprocal of time, we can get the rate of this reaction. State why it is not necessary to repeat this experiment for each halogen alkane. Most of the time, you will see that data is discontinuous, and you will see a common trend basically. So that is why if we see a common trend, and when the data is discontinuous, we don't have to. It's not kind of necessary, or we are not required to basically repeat these experiments. Because we can use the common trend and to predict the later results or the later values. Moving on, they say number 5, the alcohol 2-methyl propanol can be converted into 2-methyl propane. They say the individual steps of the method are listed. Well, these are the steps A, B, C, D, E, F. All right. The question is here, complete the list to show the correct order of the steps. So now we know what's going to happen. At first, obviously, we're going to do A, like the alcohol and the concentrated hydrochloric acid is mixed, and the flask is sealed and swirled for 20 minutes, with obviously the bung removed occasionally in order to ensure that some of the air pressure or the gases get removed. Later on, we need to add a drying agent such as anhydrous calcium chloride, and then swirl it until dissolved. And then after the solution basically gets completely separated, then later on, if we see B, we get to add sodium hydrogen carbonate solution, and the mixture is then swirled, and if there is any pressure, it will be released. The whole point is of swirling is to ensure that any pressure present gets released. The next one is that the organic liquid is distilled, and a fraction between 50 degrees Celsius and 52 degrees Celsius is collected. Uh, the aqueous layer is run off and discarded. The organic layer is run into a small conical flask, and shaken with anhydrous sodium sulfate. Again, a drying agent is required in order to ensure that any rinsings present or any water present inside the conical flask gets rubbed off. And last, obviously, that we see get to see is that before we get to do this one, E, which is obviously when the solution becomes clear, we tend to make sure the organic liquid gets decanted into a round bottom flask. So that is basically the correct order of the steps. Moving on, the next question is that describe how a solution of acidified potassium dichromate 6 and subsequent chemical tests could be used to distinguish between alcohols X, Y, and Z. Alright, you may assume that the usual laboratory glassware and chemicals were available. So if you see X, Y, and Z, what is going to happen? We are going to use this right here, that we are going to heat it with sulfuric acid and potassium dichromate 6. If I say so, when we hit this with sulfuric acid and potassium dichromate 6, what will happen for X? It will not turn from green, but only Y and Z will show a color change from orange to green. Now, why is that the case? Well, if you see this one, this is a third degree alcohol, and this is a 1 degree, and that's a 2 degree alcohol. So 1 degree and 2 degree alcohols tend to get oxidized, but third degree alcohols do not. If I talk about the next part, they said here, then we get to basically distill out the oxidation products of Y and Z. Specifically speaking, Z tends to provide an it tends to provide an aldehyde, while uh, the second degree one tends to provide a carboxylic acid. So what's going to happen is that the oxidation product of Z will obviously going to react with Benedict's reagent. Considering it is a carbonyl group, aldehyde tends to have a carbonyl. The oxidation product will be an aldehyde, and since it contains an carbonyl group, so what's going to happen? The Benedict's reagent is going to, whenever you add the Benedict's reagent, you will get to see a color change from blue solution to red precipitate. Alright, moving on, the next part, the question is about practical activities involving the collection of gases. We can clearly see out there. So, first of all, the bung was removed and 0.650 gram of copper to carbonate was added, and this is the whole process. You can clearly see, I mean the whole diagram down here, and that's the equation of the reaction provided, CuCO3 H2SO4 with copper to sulfate and water and carbon dioxide. So the first question is that after the reaction, tests can be carried out on the mixture to show that the sulfuric acid was in excess. So first question is, state the observation if a small volume of sodium hydrogen carbonate solution was added to show that the acid was in excess. So if we add sodium hydrogen carbonate, we'll get to see there is a presence of carbonate ion, right? So we'll get to see fizzing taking place because carbon dioxide gas is produced. So moving on further, if we talk about a different test and the positive observation, the if they tell you to basically basically they told you here to describe a different test, it will also provide a positive observation. uh, we can basically test the solution with blue litmus paper, and it's going to turn red in the presence of acid. Considering the acid was in excess, so obviously due to the presence of the acid, the blue litmus paper will turn red. So that's another way, that's another positive visible observation that we can see in order to show that that the acid was present in excess in the solution. The next part is that bromoethane was prepared from the reaction of ethanol with sulfuric acid, and that's the potassium bromide. The whole equation is provided. Suggest why the flask in step 2 was frequently placed in a stream of cold running water as the sulfuric acid was gradually added. They said here that in step 2 that 10 cm cube of concentrated sulfuric acid was added carefully and gradually to the ethanol in the flask. Well, first of all, ethanol is a volatile liquid and it's going to evaporate. So that is why in order to cool it down, we gradually and carefully add it slowly. We slowly and gradually add the sulfuric acid basically, and obviously, the stream of cold running water is provided as a medium for cooling, nothing else. And the potassium bromide used in step 3 was initially lumpy and not fine powder. So state the apparatus that would be suitable for breaking the lump. So we basically want to we basically want to convert this potassium bromide into fine powder. Why? Because fine powder is going to increase its surface area, and henceforth this will provide smooth boiling or ensure a faster reaction. So the best apparatus is using a pestle and a mortar, where basically in the pestle using a mortar you tend to basically crush the from particles of potassium bromide into fine powder. Now, next question is explain why orange color was seen in the round bottom flask when it was firstly gently heated in step 4. Well, in step 4, the flask was set up, the distillation and heated gently. First of all, the orange color is obviously going to be due to bromine. Why? Because the bromine is going to be produced due to the oxidation of bromide ions by the sulfuric acid. So the whole point of adding the sulfuric acid is that it basically acts as an oxidizing agent, ensuring that the bromide ions get oxidized to get produced bromine. And we know that oxidation is loss of electrons, so the bromide ions tend to lose electrons, those extra electrons, in order to produce bromine. And bromine tends to provide a brown color. Alright guys, I hope everything's been clear so far. If you're enjoying this and want to practice more papers or complete the syllabus with me before your exam, here's something for you. At Exam Essentials, we offer 2 signature courses before every session. The question papers marathon course, perfect if your exam is, you can say, is within 2 months. And obviously we got the high impact crash course. This is kind of ideal for those with 3 to 6+ months to go, focused on full concept coverage and strategy. The course details are in the description. You can also message us directly via WhatsApp at the number below or reach out on our Facebook page, Exam Essentials. Let's make your preparation smarter and stronger. So, uh, greatly expecting that you guys can join and benefit from us. Thank you. The next question says to complete the uh, level diagram for distillation apparatus used in step 4. All right, so basically all you have to do is just draw the condenser, and to ensure that uh, provide the correct direction in which the water is taken in and given out. So this is basically a lee bag condenser, and that it is always ensured that the water is taken in from the bottom while it is given out from the top. Now, identify the solid particles labeled in the labeled A in the flask that have been added to promote smooth boiling. Now, these are known as anti-bumping granules. Anti-bumping granules basically increase the surface area, which tends to provide a smoother boiling. And bromoethane is very volatile. Suggest what could be done with the small beaker used in step 5 to collect bromoethane in order to prevent the loss of the bromoethane distillate. Well, first of all, since it's volatile, we can cool the beaker using an ice water bath. Make sure to, this is the most viable option here, to cool the water bath, because if you can cool the beaker using an ice water bath, only then the temperature won't be high enough for the bromoethane to get evaporated very easily. So that's one way you can do it. Moving on, the next one, G, describe how to use a separating funnel to remove the aqueous layer from the bromoethane collected in step 6. Alright, so the densities of bromoethane include 1.47 gram per cm cube, water is 1 gram per cm cube. So first of all, after shaking and allowing the layers to settle down, the separating funnels basically are going to show 2 layers, with bromoethane being the lower layer and water being the upper layer. More specifically speaking, in many mark schemes, you might also see the aqueous layer being used instead of water. And obviously the bromoethane layer is separated by opening the tap, and obviously it's discarded off. State why the bromoethane would not be dried in step 7 by placing in a warm oven. First of all, if we do that, since bromoethane is a volatile liquid, so if we keep this in a warm oven, the temperature or the surrounding temperature would be that much high that it would itself evaporate before any water is removed, which we do not want to happen. Number 3, the equilibrium below iodine 1 chloride, chlorine iodine 2 chloride can be used to demonstrate the effects of changing conditions in a system at equilibrium. So this is the system basically described down here. The question here was the addition of more liquid P to the flask on the left produces more chlorine gas. Explain the observations you would make as the amount of chlorine gas in the U tube increases. So what's going to happen here? First of all, in the YouTube, as the amount of chlorine gas increases, basically as the concentration increases, what's going to happen? More ICL is going to get produced, considering if chlorine's concentration increases, so more ICL will be produced. So, and we know ICL is brown in color, right? So if the IC, since the ICL is brown in color, we clearly see from here. So obviously the brown liquid which is already present, it's going to become more darker brown in color, and this will cause the position of the equilibrium to shift to the right side in this way, because obviously the concentration of the reactant side increases. So in a sense we can say ICL3 increase, production increases, and we'll also be able to see the production of more yellow solid produced in the YouTube as well. Moving on, a three-way tap can be used to prevent more chlorine gas from entering the equilibrium system. Identify Q and state why it is necessary. Now, this is Q down here. Now, Q is basically a fume cupboard, because we tend to perform this inside a fume cupboard because chlorine gas is toxic. And since it's toxic, it's very much harmful and detrimental for our health, especially for the person who performs this experiment. Explain what you could do to the YouTube to result in more brown liquid being observed. We can also warm gently the YouTube, because if we can increase the temperature, it's going to shift the position of the equilibrium to the left and result in more brown liquid. As you can clearly see here, the value of del H is exothermic. So if we can increase the temperature, the equilibrium will shift towards the left, and that is the endothermic direction. So obviously this will cause, this will result to the production of more brown liquid. So this action is justified. This is just simple balancing. We can just simply balance it using the desired or the required coefficients, or the number of moles that represent the reactants in the products. Moving on, number 4, an experiment was carried out to determine the enthalpy change of neutralization for the reaction between sulfuric acid and sodium hydroxide. So we were provided with this procedure down here. Now, give a reason why the polystyrene cup in step 1 was placed in a beaker. Now, it was placed in a beaker basically to prevent the polystyrene cup from falling over. So if we can place this in a beaker, the stability is provided, more stability is provided, and as a result, there is it kind of greatly reduces the chance of the polystyrene cup from falling over, which we do not want. State the purpose of measuring the temperature every 30 seconds. Now, this is very important because this will help us to determine a consistent temperature before adding NaOH solution. We want to ensure whether the initial temperature remains constant before the rate of reaction begins. So that is why this step is very much crucial. Explain why the temperature was not measured in 3 minutes. Well, this is because the temperature is going to be varying, all right, because it takes time to add 50 cmp of sodium hydroxide. So due to the time taken for adding 50 cmp of sodium hydroxide completely, so it's going to take a little bit of time before the temperature settles down into a constant value. So before that, the temperature is going to be is going to be changing. So that is why at least 3 minutes we need to wait before the temperature is not measured. We need to allow the sodium hydroxide to completely react. The data from the experiment is shown. You are told to determine the maximum temperature change. All you do is just you just basically connect the dots and produce a uh, you know best fit straight line using a ruler. The initial and the final temperature is then noted down, and to calculate the change in temperature. In this case, it's 35 into 3, and that's 12 degrees Celsius. Explain why the temperature decreases over the time after after 5 minutes. So as you can clearly see that after 5 minutes, the temperature is drastically tending to decrease. This is because there is no more reaction occurring, right? And the heat is which is being produced is being lost to the surroundings. So that's one thing. Another thing is that give a possible reason why the temperature does not appear to change at various times, such as 5.5 to 6.5 minutes. Uh, we can say that because the thermometer resolution is insufficient to show the change. Yes, you can say that the values in the thermometers might be insufficient to show the change. So that's the reason why we don't get to see the temperature change at various times, such as 5.5 or 6.5 minutes. Moving on, state why the data will not result in the standard molar enthalpy change of the neutrals being calculated. Uh, Remember, for standard, one of the most standard condition is to ensure that the reaction is performed under standard conditions, such as the standard temperature, which is 298 Kelvin. We can clearly see it's not performed at 298 Kelvin, so we can write that reason that since the temperature is not is not at 298 Kelvin, so we can say that the molar enthalpy of neutralization being calculated is not standard. Moving on, when calculating enthalpy change of neutralization, two expressions are shown to be used. As you can clearly see, the famous MC del T and enthalpy change formula, which is energy transfer divided by moles. Explain why it may not be or may not be valid to assume that the specific heat capacity of water is suitable to use for this reaction. Well, if I say so, the specific heat capacity of acid or alkali is kind of different from that of water. So the assumption is not valid. That is right. Since the water specific heat capacity uh, is not it's not same, considering the mass of water as well as the density of water is kind of different from any acid or alkali, so that is why the specific heat capacity is kind of different for both. State why the number of moles of sodium hydroxides and not the number of moles of sulfur is used in the calculation for this experiment. uh, First of all, we need to ensure that the neutralization is what it is basically per mole of water, and the number of moles of sulfuric acid is the same as that of the water. So since it's kind of same, it doesn't kind of matter whether we want to take sulfuric acid or sodium hydroxide. Since it's kind of same, since the per mole of water which is being produced is kind of same as the moles of sulfuric acid being used up, so we can that easily say that it's going to create a contradiction where during our calculations. That is why it's safe to say that we should be taking number of moles of sodium hydroxide in consideration during our calculation. When a molecular ion fragment, they form a smaller ion and another type of particle. State the other type of particle form. Now that is known as obviously a free radical. Free radical is a type of radical which consists of unpaired electrons or unpaired species, charged species which consist of unpaired electrons. So that is how it gets. So the molecular ion fragment itself is going to be positively charged while the radical is going to be negatively charged. Student C used sodium hydroxide solution labeled 0.103 mole per dm cube that had been made up several months ago and stored since then. Question is, explain what effect this would have on the mean titer compared to student A. Now, if I say so, some of the water may have evaporated, causing the sodium hydroxide solution to be more concentrated. So the mean titer would be lower. Okay, so that's how it's going to work. So because since some of the water gets evaporated, so in a sense we can say the concentration of NaOH calculated is going to be high, and that is why overall we can say the it's going to act as a domino effect, causing the mean titer to be low. Seaweeds absorb iodide compounds from seawater. Now, if seaweeds are dried and heated strongly, iodine can be obtained from the ash produced. What is the procedure being used of? So these are basically the procedure: step 1, step 2, step 4, step 5, step 6. uh, so question is here, describe how to carry out step 5, which is to extract the iodine formed in step 4 using cyclohexane as a solvent. So we can use the solvent extraction process where we basically add the iodine solution as a filtrate to a separating funnel containing cyclohexane. Then we gently swirl the mixture and then invert it down to allow the to basically relieve the pressure, because uh, when you keep on mixing the components, the gas pressure tends to increase. So that is why in order to release the pressure and to ensure that the components tend to separate more efficiently, that is why it's very important to invert the separating funnel and open the tap of inverted separating funnel occasionally to relieve the pressure. Then we will again return the funnel to its upright original position and allow the layers to settle down, and then we can then discard the lower aqueous layer. The lower aqueous layer is going to be uh, the lower aqueous layer is going to be obviously the cyclohexane, while the iodine remains at the top. Moving on, ethanol can be prepared by heating ethanol with acidified sodium dichromate 6. Okay, so the question here is that explain why the reaction mixture is heated as shown instead of heating under reflux. Well, first of all, you have to understand that distillation allows the removal of aldehyde as it forms. So if since it does, I mean since this is done, so what happens is that this kind of prevent the formation of a carboxylic acid. We know that distillation kind of helps to separate components according to their varying boiling temperatures. So as soon as the aldehyde is formed, it is kind of separated and collected in around bottom flask. Okay, so this is going to further prevent the aldehyde or the further prevent the mixture to oxidize and produce carboxylic acid. So explain why the water is passed through the condenser in the direction shown. This is very important as why this is very important that the water is passed this way. We have clearly seen a little while ago in a previous question that the water either basically flows out from like this if the Liebig condenser consists of a pipe above, or it could be something like this as well. It could be below. Now, why? This is because it kind of ensures that the condenser is I mean, the why we do this, because this kind of ensures that the condenser is full of water, and this is very important because this will prevent the formation of air bubbles, because if air bubbles are produced, the cooling process will become less efficient, which we do not want. So this is why the way in which the water is absorbed and given out, this is very important. Student is given three solids, compound A, B, and C. So each solid contains the cation and one anion. So two of the cations are known to be sodium and potassium. We can see that. So the student carried out flame tests on separate samples of each solid to identify the cation image. Describe the method for carrying out a flame test. First of all, what we need to do, we need to clean a piece of platinum wire by dipping into hydrochloric acid first. Then we basically dip the loop of wire into the sample to be tested and place it over a non-luminous blue Bunsen flame. So this is the usual flame test we need to do, because obviously the platinum wire has to be dipped in the hydrochloric acid first to ensure that uh, you know to ensure that basically if there is any sort of carbonate ions present, we can remove it off, and then into the sample being tested and places of a non-luminous blue Bunsen flame. Now, non-luminous blue Bunsen flame is also important, considering that we do not want the cation's flame color to be mixed with the with the Bunsen flames itself. So that's why Bunsen flames color itself. So that is why it's important that the Bunsen flame should be non-luminous blue. They said here, complete the table of results. You have A, B, C. Flame color yellow, lilac, and pale green. So these are the formulas of the cation present. You got this. So next question here. They said compounds A, B, and C each contain a different anion. Describe the chemical tests on the precipitates formed in B that could be used to confirm which anion was present in each compound. I need to give the results of each test. First of all, add the dilute ammonia solution to each sample. Only silver chloride precipitate dissolves. Obviously, this is very important. This is like a further extension of halide test of halide. So that is why if we add ammonia solution to each sample, the silver chloride is going to dissolve. And if we add concentrated ammonia solution to each sample, the only thing that's going to dissolve is the halides of chloride and bromide, but the silver iodide remains insoluble. So these are two ways, basically extension of halide test, because sometimes the production of white, cream, and yellow precipitate isn't enough to judge which halide is present in the solution, or which anion is present in the solution. Now, the molar volume of carbon dioxide may be determined using the reaction between calcium carbonate and ethanoic acid, because obviously carbon dioxide is produced in this reaction. This is the process. They said here, draw a diagram of the apparatus which is used to carry out the reaction and collect the carbon dioxide produced over water in a 100 cm cube measuring cylinder. Okay, so this is basically the over water method. We can clearly see that we need to ensure that the pipe which is connected, it is ensured that it is present or fully present underwater in a beaker, because if we do that, bubbles may come out. So if we tend to keep so we need to ensure that no gap is present between the opening of the pipe and obviously the water, because if there is any gap present, there is a high chance that there might be a gas leakage, and bubbles of gases or water bubbles may be produced, or air bubbles may be produced over the surface, which indicates that gas is being lost. So we do not want that. We want all the gas to be present inside this measuring cylinder so that it can be collected and calculated. Explain why ethanoic acid is used and not hydrochloric acid. Okay, so in this case, the ethanoic acid is a weak acid and hydrochloric acid is a strong acid. So if the hydrochloric acid was used, the gas would have escaped before the bung could be quickly replaced and the test tube sealed. So that is why it's important. Weak acid is being used, not strong acid such as hydrochloric acid, because obviously the reaction would be very much vigorous before you and the products will be produced at a very fast rate, and it will be kind of very much difficult to prevent the products from being escaped. Cyclohexene may be prepared from cyclohexanol using 85% phosphoric 5 acid. So you got a simplified procedure of the preparation shown, and the data is provided down here. Now, bottles of cyclohexanol and cyclohexene have the hazard symbols down here. You got cyclohexanol and cyclohexene. and this kind of indicates this hazardous symbol indicates the hazard is flammable, and for cyclohexane it's kind of harmful to the environment. So now they told you to complete by identifying the hazards. That's how you're gonna do. Always remember that whenever there is a hazard symbol with fire and with the circular with a circular thing at the center, that would be something called oxidizing agent. Oxidizing, the hazard would be oxidizing, considering it is kind of not directly flame level, but this kind of indicates that the agent over which the hazard symbol is provided at the bottle or whatever which contains the agent, that is an oxidizing agent. Now, for each compound, state one way in which the risk due to the hazard shown could be reduced when carrying out the preparation. Now, obviously, since cyclohexanol is flammable, we can say we have to heat it using a water bath so that the temperature remains mildly cooler. And for cyclohexane, since this indicates that it's kind of harmful to the environment, so we can use an organic waste bottle, or in order to ensure that the waste being produced during this reaction is stored in this bottle, because we don't want to dispose this waste down the drain, which will be detrimental to the environment. State how anti-bumping granules make the liquids more swiftly. Well, first of all, the anti-bumping granules tend to provide more nucleation sites, or in other words, they provide more nucleus. All right, nucleus are basically spaces on which gas bubbles tend to grow. So basically another thing is that you can also say, since the nucleation sites are pretty much small, so this kind of ensure that the gas bubbles which are produced are pretty much small, and also prevent the production of large gas bubbles, because since the nucleation sites are pretty much small by itself, so obviously there is no chance of producing large gas bubbles. So providing more nucleation sites is going to drastically increase the boiling rate, and it's going to be very much smooth basically. Anyways, the diagram shows the apparatus used for fractional distillation in step 4. So this is the diagram. Fractional distillation is basically the process in which the components in a mixture are separated according to their boiling temperatures. Why is used rather than simple? First of all, fractional distillation will provide a better separation of cyclohexane water in the reaction flask than simple distillation, simply because they have varying boiling temperature. Cyclohexane has like somewhat about 125, while water is a boiling temperature of 100. So obviously the water is going to boil first before the cyclohexane is left. And another thing is that fractional distillation will all the column basically is going to provide longer reaction time, so it kind of acts like a reflux condenser. Obviously we are all familiar with heat under reflux, the whose main sole purpose is to ensure that the reaction goes into completion. So yeah, in this case the fractionating column down here, this one down here, basically acts as a reflux condenser. Moving on to our diagram of the separating funnel and its contents in step 5, labeling each layer. So we need to draw the solvent extraction process instrument. So you can clearly see water is the aqueous layer, is always going to stay down, while cyclohexane tends to settle down at the top, considering due to the varying densities, the water one's heavier compared to cyclohexane. Now explain the change in the appearance of the liquid when it is allowed to stand with anhydrous calcium chloride in step 6. Now, first of all, you need to see that anhydrous calcium chloride is what? It's a drying agent, right? So obviously, it will absorb the water, right? So if it absorbs the water, the organic layer, obviously the cyclohexane, the appearance of this liquid is going to turn from cloudy to clear due to the absorption of water. The student refilled the burette and prepared a second conical flask by adding sodium carbonate solution, methyl orange indicator. So the titration process basically, we need to add the acid from the burette quickly until the rough endpoint is reached, and near the endpoint we need to slowly add the acid dropwise while swirling, because the swirling is required to ensure that the mixture tends to mix more evenly, the components tend to settle down or distribute equally towards the whole mixture. And obviously we need to do this until the indicator changes color, which kind of indicates that the neutralization process is completely complete. The next question says it's about two ionic compounds A and B. Compound A is a white crystalline solid, contains one cation and one anion. A flame test was carried out on solid A and a pale green color was observed. So identify by the name or formula the cation present in A, this it. So you have, obviously it's going to be Ba2 plus, obviously, because a pale green color is only shown by the Ba2 plus cation. An aqueous silver nitrate acidified with sodium with dilute nitric acid was added to a sample of solid air dissolved in distilled water. Yellow precipitate was produced. Now, obviously, a yellow precipitate indicates the presence of iodide ion, and obviously, the formula would be, if you just add them up, it's going to be barium iodide. Again, the anion A can be shown by a different test on solid A. So give a suitable different test with the expected result to show the identity of the anion. So if I say so, uh, obviously we can add sulfuric acid with it, and if we can add concentrated sulfuric acid, purple fumes, and bad egg smell. Bad egg smell is basically due to the production of uh, hydrogen sulfide, and that's how it works basically. So, in order to ensure, the purple fumes are basically due to the production of iodine gas. So that is why that's another way we can ensure that iodide ions are present in this solution. Moving on, solute B is ammonium sulfate. So give a test with the expected results to confirm the presence of ammonium ion in B. So you add sodium hydroxide solution and you warm. You test the gas release with temperature. It's going to turn blue because obviously ammonia gas is the only alkaline gas that we get to see in AS level. So it's going to turn blue. Litmus paper. And to confirm the presence of sulfate ion is basically the test of sulfate, right? What you do is you add dilute hydrochloric acid in to ensure that no carbonate ions are present, and then you tend to add barium chloride solution. The white precipitate produced is basically barium sulfate. So that's how it works. All right, moving on to the next part. Basically, the next question here is the tests are carried out to identify two liquid organic compounds C and D. So you got a small amount of this one right here. So everything is provided. Observations for misty fumes are given up, and misty fumes are given up. So this kind of indicates the presence of OH group. So we can say, and the misty fume is basically due to the production of hydrogen chloride gas. If I talk about this, the next test, it says here hydrogen carbonate is added to separate 2 cm of samples of each compound. Any gas given as test with litmus water, we see a lime water turns cloudy, and this one doesn't turn cloudy. So obviously C must contain the carboxylic group while D doesn't, because carbon dioxide gas is not produced, and obviously the formula is this one. Next question here, they said Benedict's or Fellings solution is added. Again, we tend to use Benedict's or Fellings in order to see the presence of what's it called, carbonyl groups, more specifically speaking aldehyde. So obviously whichever one reacts, we can clearly see that D reacts, so D will have aldehyde group, while the other one might be a ketone or a carboxylic acid. Okay, so the positive result that's going to be seen is that the blue solution of Benedict's is going to turn brick red precipitate in the case of D. So both C and D have the molecular formula, and now that we know, now that we have deducted correctly which compound contains which functional group according to our tests, we can just draw the possible structures of C, D, and D. Now obviously D could be a carboxylic acid, or it could be obviously it could be ketone as well. So we do not know. So I mean C is basically carboxylic acid, right? And we do not know which one is a ketone. Obviously we can see that for D is going to be an aldehyde, so that's how it goes, and this is going to be an aldehyde as well. So we do not know C could be a carboxylic acid or a ketone. We can try any one of them. Now the question is about the reactions of butanol. They said so this a group of students is required to oxidize butanol, we can see, to butanoic acid, and the students suggested three types of apparatus for this reaction. You was E, F, and G. Now suggest why E is not suitable for the oxidation of butanol to butanoic acid. This is very important because E is not suitable because you will see that this is the simple distillation apparatus, right? So what's going to happen? The distillation will take place before the complete oxidation occurs. So only the aldehyde will be produced, right? And there is no reflux, heat under reflux present. So complete oxidation might not take place, and complete oxidation is required for the production of carboxylic acid. So that is why overall we can say apparatus is not suitable for the oxidation of butanol or butanoic acid. Now give a different reason why apparatus G is not suitable for the oxidation of butanol or butanoic acid. If I talk about apparatus G down here, what is happening is that we do not see any bung. Do we see any bung? We do not see any bung in this round bottom flask. So the reactants are obviously going to escape or evaporate. So obviously it's not going to, even though the oxidation takes place, it's not going to work. Explain why in apparatus F the water should flow in the bottom of the condenser. First of all, this is again the same reason little while ago we saw, that for efficient condensation and to prevent the production of air bubbles. So this is one common question we have which we have encountered previously, and now we have encountered it as well. So this is a very important question. Do try to keep an extra care on this type of question. Moving on, the state the reaction mixture that can be carried out to oxidize butanol or butanoic acid. Again, if you want to oxidize, we will be requiring an oxidizing agent along with dilute sulfuric acid. So this is very important. The combination, the dilute sulfuric acid ensures the oxidizing agent efficiently works. And the color change will obviously be from orange to green, because obviously whenever an oxidation product is produced, the color of K2Cr2O7 changes. Tends to get oxidized, because obviously the Cr7 plus goes from to Cr3 plus. Name a suitable chemical reagent to carry out this elimination reaction. Obviously, if you want to convert some alcohol to alkene, we need to perform an elimination reaction, and only possible base of phosphoric acid, which is H3PO4. This is basically they're trying to tell you, to determine the presence of carbon to carbon double bond here. So obviously it's a test of unsaturation. You add bromine water, and if we see a color change basically from orange to colorless, so obviously we'll see that there is the presence of carbon to carbon double bond. And if you do not see any color change, so obviously there won't be any uh, color change. All right, moving on. Number 4. The question is about calcium and calcium hydroxide. So this is like the procedure down here. You have step 1, step 2, step 3, step 4, and this is the part. And these are the results. You can clearly see. State 2 observations when this reaction takes place. Effervescence, obviously, because obviously we know that hydrogen gas is produced, and the calcium metal solid gradually gets smaller and disappears, obviously. And at one point you will see white precipitate will be produced due to the production of calcium hydroxide, which is slightly soluble in water, considering slake lime is produced and quick lime. Slake lime is the one reason why it's white precipitate. The student then repeated the experiment with using the same apparatus, and you can see basically they got different data book values. You can clearly see the data book value was this much, but they got a completely different value. So state how the changes in the experiment improve the percentage uncertainties in the measurement of mass and temperature. um, Look, the percentage uncertainty is what we know, that measured value. This is what the formula is: measured value, obviously the uncertainty times the number of times the measured value is taken times 100. So if we can increase the value of the measured value, the percentage uncertainty decreases, right? So that is why we should increase the mass of the ethanol burned, which will greatly reduce the percentage uncertainty and kind of basically increase the accuracy between the data booklet value and the experimental result. Explain how the difference between uncertainty and accuracy led the teacher to make this statement. Because uncertainty values indicate the range over which the measured value is valid, right? So the accuracy is an indication of the difference between the experimental and the data book value. Yeah, that's right. So uh, the accuracy is measured on the terms of uncertainty, percentage uncertainty value. And what is accuracy? We all know it's basically the difference between the real experimental value and the data book value. So this kind of act is a measuring factor of accuracy, the percentage uncertainty. You can see the citric acid is used as a descaler to remove lime scale from kettles and coffee machines. So you got citric acid down here, and this is solution A. The procedure is provided down here. We can clearly see. The question here is give a reason why the student inverted the volumetric flask several times in step 1, because this kind of ensures that the solution has the same concentration throughout, right? What's going to happen is the solution is going to get evenly distributed, so the molecules will, in other words, will get evenly distributed, and that is why the concentration will remain the same throughout. Now the alcohols, KLM, are isomers of butanol, the alcohol down here. So we need to basically to again the same chemical test for determining the presence of OH group. In a dry test tube, you tend to add a small portion of PCl5 and mixed fumes will be produced, which is obviously HCl. Again, if you want to convert, what's going to happen? Like if you want to oxidize butanol, potassium dichromate 6, the same thing a little while ago we saw in a previous question. It's going to be orange to green, the color change, which kind of ensures that the oxidation product has been produced. Again, with portions of solution in dilute sulfuric acid. So no color change is kind of observed with isomer K. So obviously, the third degree alcohols or tertiary alcohols do not tend to go the oxidation process when oxidizing agents are added. So we can clearly say you can either give any tertiary alcohol. I mean, it could be a 2-degree alcohol, something like this, or it could be a third degree alcohol, something like this. So you can give any one of them. The marks will be provided because both of them makes logic. All right, moving on. The isomers L and M are oxidized when warmed with solutions of potassium dichromate 6 in dilute sulfuric acid. You can clearly see that. Complete the table to show the displayed formula of these two isomers, and the product of the oxidation products is isomer L. All right, so you have secondary L and this is primary M, obviously. So you just draw according to the values down here. We can clearly see the oxidation product of a second degree alcohol is just going to be a ketone, while the primary alcohol is going to be obviously, and I think it's going to be an aldehyde. Yes, it's going to be an aldehyde. So that's how it goes. And L is obviously ketone, M is aldehyde. How can we distinguish between them? When we add Benedict solution and warm it up, no reaction is going to take place for the ketone part, but for brick red precipitate will be produced for the aldehyde part. So that is why we can say, that is how we can distinguish between L and M. In the test for sulfate ions, an acid is added. Now, why do you think the mixture must be acidified? Well, a little while ago in a previous question, I said that to remove insoluble barium compounds other than barium sulfate, because the insoluble barium compounds such as barium carbonate, barium carbonate is a prime example. Let's say these compounds are insoluble, right? So they would otherwise react and form white precipitate, and we don't want these white precipitates to mask the color of barium sulfate, which is white itself. So that is why there's going to be a contradiction, and it is very much important to remove these barium compounds, if any, present by acidifying the mixture before adding the barium chloride. Okay, identify by name or formula suitable acid and justify your answer. Obviously, a strong acid such as hydrochloric acid is suitable because it's not going to precipitate barium ions, because barium chloride is kind of suitable. So it's very important that we get choose someone which is an anion which kind of reacts with barium ions and produces a soluble compound. Okay, because the compound produced has to be soluble so that precipitates are not produced. Describe how the test should be carried out, including the positive result. Obviously, you need to dissolve the crystals in the deionized outer water first, because they might act as a hindrance, and then you perform the usual test of sulfate. Next question, propan 1-ol, propan 2-ol, and 2-methyl propan 2-ol are alcohols commonly used in school laboratories. Again, they told you to state the color change when an alcohol is oxidized using acidified potassium dichromate 6. You just give orange to green, and that's how it works. Pretty simple. We have seen countless times. Again, they told you to draw a label diagram of the apparatus. This question is very much common in a lot of years, in from 2025 to 2019. Many times the process of answering these drawing questions, basically simple distillation process, apparatus drawing, is kind of similar. Just ensure that the direction signs of the water out and water in remains like something like this. In some mark scheme you might see that water out is given down like something like this, while water in is given this way. It remains constant. So it doesn't matter. A little while ago we saw that, right? So it doesn't matter. You can give either the water out here, or you can also give the water out below the condenser as well. It doesn't matter. It's the same thing. But ensure that the correct labeling is provided, because that kind of carries the marks. An electric heater may be used to heat a sample of an alcohol with acidified dichromate 6. Now, first of all, electric heater is obviously more preferable compared to a Bunsen burner, considering alcohol is flammable. All right, an electric heater provides the safety and allows the alcohol to not split up, because if it splits up, the alcohol, since it's flammable, and Bunsen burner being it, since it's not an uncontrolled flame, since it's not a controlled flame, so the alcohol splitting out might cause further reaction and cause damage to the apparatus. Now give a further chemical tests and the positive results for each of the oxidation products of propan 1. Now for oxidation product, since it's a first degree alcohol, we can safely assume an aldehyde is produced, which is propanol. And for distinguishing propanol from another carbonyl compound, we can easily add Benedict's reagent and warm gently. So what going to happen is that you see a color change from blue solution to red precipitate, and the other product which might be produced, which is carboxylic acid, right? So we don't know, carboxylic acid might be produced as well. So for testing the presence of carboxylic group, we can just add sodium hydrogen carbonate solution, and due to the presence of carbonate, so carbon dioxide will produce, which is a fizzing gas. We can just give a the whole point of giving producing carbon dioxide gas is to ensure the is to pass it through lime water, and if it's carbon dioxide gas, the lime water will turn milky, and that is how we can ensure that carbon dioxide gas was there, or there is the test carboxylic group is present in that compound. Okay. Okay. The next part of the question is that the hydrogen carbonate of an unknown one metal is a white solid. So students carried out a titration experiment using hydrochloric acid. The results were basically used to determine a value for the relative formula mass of this. So this is the whole process provided. The question was, the first student suggested the bullet was the biggest source of experimental uncertainty, and explain how the percentage uncertainty of the bullet rating could be reduced without changing the apparatus. Now, again, the same thing, we can just increase the mass of the metal hydrogen carbonate used, or we can simply just decrease the concentration of hydrochloric acid. So both are in terms is going to, the whole point here to increase or decrease the concentration is that both are going to increase the titration volume. So increasing the titration volume, measured titration volume, is going to reduce the percentage uncertainty because they are kind of inversely proportional to each other. So that is why it's important. Again, the second student was told that using a beaker to prepare their standard solution, which is incorrect. Describe the steps the student should take to make a standard solution as accurately as possible. First of all, he can dissolve the solid in deionized water in a beaker and then pour the solution into a volumetric flask, obviously using a funnel by rinsing it. We need to rinse it down and to ensure that any washings present at the interior surface of the uh, volumetric flask must also be transferred. And then later on, you need to make the volumetric flask up to 250 cm cube mark and then shake it down. That's how it works. Cyclohexene was then prepared by dehydrating cyclohexanol using concentrated phosphoric 5 acid, and that's it. Basically, you can see the procedure. All right, the process has been provided. Everything, the temperature is also provided. Now, after washing in step 5, the separating funnel contains 2 layers. So again, you need to draw the apparatus which involves the solvent extraction process. Again, water is going to be present since at the bottom layer, while cyclohexene at the top, considering it as a greater water has a greater density, we can clearly see compared to cyclohexene. So that's how it's gonna get removed, get separated. So this is what might be removed by washing the product with deionized water in step 6. So with doing that, we can remove the cyclohexanol once and for all because we do not require that. We require the separation of cyclohexane water in 2 layers. That is how it works. Again, identify from the list shown one substance that could be used as a drying agent. From this, obviously, magnesium sulfate is the most suitable because we do not want this to, considering it is hydrated. This one contains OH group, and this is an acid. So, and that's also that's an alkali. So the only option is magnesium sulfate because it does not contain water, and it doesn't react, unlike the others which kind of react and contains of water. Moving on, they said here a student investigated the enthalpy change when dissolving NH4Cl in excess water. So the reaction and the procedure is provided. So they said here the experimental results of another student were used in the equation shown. So all you need to do is basically use this equation and solve it. Now, what are the two assumptions of this calculation? The assumption was pretty simple, that the volume of the solution was taken as its mass. Why? Because the solution has a density of 1 gram per cm cube, so we are considering 1 cm cube of the solution is equal to 1 gram. All right, and obviously the mass of NH4Cl was ignored, while the specific heat capacity of the solution was assumed to be the same as water, which is not kind of same, but this is kind I mean, in reality it's not same, but obviously we assumed it for simplifying our calculations. All right, now this question is about two organic compounds X and Y, both which are liquids containing carbon, hydrogen, oxygen. Basically there might be hydrocarbons, most probably. State the measurements that should be made in this apparatus. So we need to measure the mass of each U-tube and their contents before and after the combustion, because that's how it works. Before the combustion, we'll be seeing some components being absorbed, while after the combustion, some components will be produced. So obviously we'll see a change in the mass before and after the combustion. Again, the same apparatus which we need to draw, and we have seen this similar question previously in many questions previously in this video, so it's nothing new. You just need to draw the level diagram of simple distillation apparatus. Again, number 4, the question is about the preparation of anhydrous aluminum chloride, AlCl3, which you can see, which kind of reacts vigorously with water and must be stored in tightly sealed containers. So this is, you can clearly see this is the procedure, the whole apparatus provided, and that's the procedure: step 1, step 2, step 3, step 4. Now the question here is that granules of anhydrous calcium chloride are held between two ceramic wool plugs in the combustion tube. What is the purpose of anhydrous calcium chloride? Now, first of all, it will act as a drying agent, which is to absorb water, because the water might react with the product aluminum chloride and lead to the production of a substitution, or an alternative product, which we do not desire to have. So that is why a drying agent is required to, you know, absorb all the water. Now, give a reason why the granules of anhydrous calcium chloride are used rather than powder. Obviously, again, to ensure smooth boiling and enable the gases to pass through easily. You can write any one of them. The reaction in step 2 produces chlorine gas. Now, the hazard, always remember, we have seen this before in our previous questions as well of unit 2 and unit was that the only hazard related to chlorine gas is it's toxic in nature. And that is why the safety precaution for any experiment which involves the production of chlorine gas is to ensure that the experiment is performed inside a fume cupboard. All right, so it's nothing new. Give a reason why the concentrated hydrochloric acid is added drop by drop. Now, drop by drop is all gradual, slow. It's very important because it kind of prevents the chlorine gas from being produced too quickly, which we do not want. Because if chlorine gas is produced very quickly, then we won't be able to control the rate of reaction, and the measured values will have greater level of inaccuracies when we calculate during our calculations. Now, moving on, so this is why the heating of the aluminum step 3 is delayed by 20 seconds after the initial production of chlorine gas. While this is to prevent the oxygen reacting with the aluminum before the chlorine gas could displace the air from the apparatus. So, if the oxygen reacts quickly with the aluminum before the chlorine gas, then the whole reactions will alter and something else will be produced, which we do not want. All right. Next question here is that state how you know the reaction is complete in step 3, when obviously the aluminum stops glowing and when no aluminum foil remains, and obviously when all the aluminum has turned white. So these are the processes which are very much required. Suggest the purpose of the potassium hydroxide in the absorption tube. This is to basically absorb the unreacted chlorine gas. No, 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 no surprise here. Now, geraniol is used in perfumes and can be extracted from many plants. So the data on geraniol are shown. You can see the melting temperature, boiling temperature, the density down here. Now, geraniol has two different types of functional group. Name the functional groups, give a chemical test, and its positive results to show the presence. Obviously, the first functional group is alkene, and you just do the unsaturation test of unsaturation. You add bromine water, and you'll see a color change. Basically, it becomes colorless from orange to colorless. Again, we see an alcohol group at PCl5, the usual PCl5, and misty fumes will be seen, right? One way you can see misty fumes, and this will basically, I mean, how do you identify the presence of HCl gas? You can just, you know, uh, you know, bring a damp blue litmus paper, which is going to turn red because HCl gas is acidic in nature. Again, geraniol is extracted by steam distillation process. You see the whole apparatus down here. The steam distillation product is geraniol water. Again, the same thing, to draw a level diagram of the apparatus which kind of separates geraniol water. The solvent extraction process, we tend to use a separating funnel here. Geraniol at the top while water at the bottom, considering water has a greater density. Geraniol will still contain small quantities of water. So describe how to produce a sample of pure dry geraniol using a named drying agent. We can use calcium chloride, any suitable drying agent, and then, after the drying agent basically performs its role. Basically, how will you understand this? When the color changes when the organic layer changes its color from cloudy to clear, considering all the water has been absorbed, confirming all the water has been absorbed, and then you can just separate the drying agent by filtering off the liquid or discarding it. Again, the hazard symbols for pure geraniol is shown. It's flammable, corrosive, obviously moderate health hazard. Complete the table to identify the hazards indicated by the symbol. All right, state one precaution other than wearing safety spectacles and a laboratory coat that should be taken when using pure geraniol to reduce the risk associated with the hazard symbol. So since it's corrosive, we need to wear safety gloves, because small amounts of we can also make sure to cover the bottle containing the corrosive liquid with lids, because this will keep off our hands from corrosive liquids. When geraniol is indicated, we'll tend to see a smoky flame, considering it is flammable. Geranyl reacts with excess hydrogen gas. The essential condition will obviously be a nickel catalyst, because whenever we react something with hydrogen gas, a nickel catalyst is required. Draw the skeletal formula of the production of this reaction. So when we add hydrogen gas, what's going to happen? Hydrogenation takes place in the part where the double bond is present of alkene, of carbon to carbon double bond. That's going to break down and hydrogen is going to get added. The value of the enthalpy change from the experiment was this. So one possible reason why this value is from a data booklet below. Many common reason, you can just give heat loss to the surrounding, or the mass of solution was more than 25 gram, or you could say the polystyrene cups, any issue related to the polystyrene cup. All right, so any reason is suitable, but it has to be logical. So the next question is obviously we need to use the Hess law in order to calculate the enthalpy change of hydration. So this is just simple Hess law. All you have to do. So it's nothing new here. All the values are provided. Moving on, give one possible reason why the enthalpy change of hydration in D1 could not be found directly by the experiment. Because first of all, see, it is kind of very difficult to add the correct amount of water, right? Or you can say, since we have a solid involved, to measure the temperature change of a solid is kind of very difficult. So clearly, the value of enthalpy change of hydration cannot be easily or directly found by the experiment. It becomes very tough. The white solids, sodium sulfate and potassium carbonate, may be distinguished using a flame test. Identify a material from which the flame test wire could be made and justify your answer. Now, look, it could be made of nichrome or platinum, as it is inert, and it kind of does not produce any flame colors that will interfere with the test, right? This is very important. Describe how to carry out a flame test on a solid, giving the expected flame color for each of the compounds. First of all, you clean the nichrome wire by dipping it in concentrated hydrochloric acid and then onto a flame until no color shows. Then dip the loop of wire into the solid sample and hold it onto the edge of non-luminous Bunsen flame. Again, it's the usual flame test, nothing else. Sodium sulfate, due to the presence of sodium, will provide a yellow flame, while potassium one will provide a lilac flame. So it's not it's the usual flame test. Moving on, sodium sulfate and potassium carbonate may also be distinguished using chemical tests. So provide a chemical test for each compound which should confirm the identity of the anion. Include the expected results. So you got test 1, you got test 2. Obviously, sodium sulfate, right? So if we add dilute hydrochloric acid to sodium sulfate and a few drops of barium chloride solution, this is basically a test of sulfate. So white precipitate, basically barium sulfate, will be produced in the case of sodium sulfate, but for potassium carbonate it won't be. For potassium carbonate, how can we distinguish the production of carbonate, which is the another anion, and the another anion for this was SO2 minus. So for carbonate, we can just add dilute hydrochloric acid, and after that, following potassium carbonate. So this will basically, provoke the reaction, provoke the production of carbon dioxide, and which we can basically prove by passing it through lime water, because the lime water will turn milky due to the production of calcium hydroxide. Moving on, the next question is about the reaction of three compounds with formula C6H12O, and the compounds are cyclohexanol, hexane 3 and 1-ol, and we have one methyl cyclopentanol. Give a chemical test to show the presence of OH group in all three compounds. So you basically add solid PCl5 to each compound. The misty fumes of HCl will be produced that turns damped lead repulsible red, because obviously HCl gas is acidic in nature. We have seen this same question previously in our video in another question of another year. So give a chemical test to show the presence of the carbon to carbon double bond in Z hexane hex 3 1-ol, including the expected result. So you tend to add bromine water to the sample. There is a color change from orange to colorless, and you're going to add KMnO4 and sulfuric acid. Color change will be from purple to colorless. The test you have given in B1 is repeated with 1-methyl cyclopentanol. Give the observation for this test. With no color change, the solution remains kind of orange, because we do not see any color change for 1-methyl cyclopentan 1-ol, unlike the one for Z hexane 3 and 1-ol. Moving on, separate samples of each of these compounds was warmed with acidified dichromate 6. Complete the table to provide the color changes if observed, if any. For this, we will see orange to green due to alcohol group. We'll also see orange to green because it's a first degree alcohol, but we won't see any color change for this case, because in this case we can clearly see this is the carbon which is connected to the OH. It is kind of tertiary, so tertiary alcohols don't get oxidized. Saturated solution of barium hydroxide was formed by adding barium oxide to water until no more would dissolve, right? So the question here is that the resulting mixture was again filtered to remove excess solid. Now the concentration of the barium hydroxide solution was found by titrating portions of the saturated solution with hydrochloric acid of known concentration. So 10 cm portions is added. State the color change at the endpoint. So since methyl orange is indicated, obviously it's going to turn from yellow to orange. Considering the acid tends to neutralize in case of the alkali and in acidic conditions, the methyl orange indicator tends to show orange. Some of the results are shown. Basically that told you to complete the table. Basically the all you have to do is just find the titers. Another reason why the first titer should not be used to declare the mean titer, because it's not concordant with others. Concordant titers are basically titers which have a difference of not within 0.2 cm cube. I mean, the if the difference values, if the difference between the titer values are not within 0.2 cm cube, then it's not considered as concordant titers. Only the concordant titers are taken to find the average value of titers. Uh, Number 4, a sample of 1 bromobutane may be prepared by reacting butanol with sodium bromide and 50% concentrated sulfuric acid. So you have step 1, step 2, step 3, step 4, step 5, step 6, and the data has been provided. So suggest why the percentage yield of 1 bromobutane might be lower if the cold water bath was not used in step 1. Look, first of all, the reaction is exothermic. All right. So if the reaction is exothermic, what's going to happen? Heat will be given off. So this might cause the mixture to boil, because we have we can clearly see the temperature down here, which is kind of very low, making 1 bromobutane and butanol volatile in nature. So this might cause the reactant or the products to escape, which we do not want to happen. So this is why it's very important that what's it called, that it is very important that the reaction is performed under a cold water bath, because this will keep the whole temperature cool, and not let the temperature have high become high enough to ensure that the reactants and the products do not escape by evaporation. Moving on, state what must be added to the mixture in the flask in step 2. All right, anti-bumping granules, right? In step 2 you can clearly see you need to heat the mixture in the flask under reflux for about 45 minutes. So to ensure smooth boiling, anti-bumping granules are very much necessary. Draw a level diagram in the apparatus that you would use to heat the mixture under reflux in step 2. Obviously this heat under reflux, the the common heat under reflux apparatus, make sure the arrow signs of water in and water out is same. It shouldn't be like this. If you do that, one mark will be cross. And why do we do that? Because in order to ensure that no air bubbles are produced inside the condenser, and the cooling process is much more efficient. The purification of the product occurs in steps 2 to 6. Basically from uh, this part to this part. So the question here is that state why the sodium hydrogen carbonate solution is added in step 4. Well, basically to neutralize the excess sulfuric acid, because if any sulfuric acid is present, it's very much necessary to neutralize it using sodium hydrogen carbonate. Moving on to the next part, addition of sodium hydrogen carbonate solution in step 4 causes the vigorous effervescence. Explain how the problem associated with step 4 should be dealt with. Now look, vigorous effervescence leads to a buildup of pressure in the separating funnel. So the funnel is kind of inverted and the tap is open. This is very much necessary because we have seen this process in previous question as well. Why is it done? Because during the separating solvent extraction process, the gases tend to get accumulated inside the separating funnel, increasing the pressure. So that is why this process is performed in order to relieve the pressure, basically to release the gas. So in other terms, the pressure is released. So this is very important. The purpose of obviously anhydrous calcium chloride is act as a drying agent. And when will we understand the drying agent is completely performed its role is that when we will see the organic layer being turning from cloudy to clear, ensuring that all the water has been absorbed. For the final distillation in step 6, a thermometer we can see with scale giving readings to the nearest 1 degree Celsius provided give a suitable temperature range for the collection of the pure 1 bromobutane. We can give from 101 to 103 degrees Celsius, considering the boiling temperature of both the values is provided down here from 118 to 102. So temperature between 101 and 103 is very much important. A student was asked to prepare 20 cm cube of 1 bromobutane using the procedure described. The student knew that the percentage yield would be less than 100%. Give one possible reason. Well, there are very much possible reasons. Basically, maybe side reactions may occur leading to unwanted products, production of unwanted products, incomplete reaction, which means not all products might be produced. I mean, not completely the products might be produced. Some might be produced, and obviously, during decantation. In other words, you can say that during filtration, uh, some products might get lost to the surroundings. This is very much important. All right. Moving on, the next part is that sodium hydroxide solution reacts with carbon dioxide in the air and should be standardized before use. Now, ethane dioic acid may be used for this standardization. You got this. Now, give a possible reason why any solution remaining in the beaker is washed into the volumetric flask before making up to the mark. This is because that all the reactant or the solution waked out are transferred to the volumetric flask, so that none of the reactants waked out are left behind the figure in the beaker. So this kind of ensures that all of the reactants gets transferred. Literally, all of them gets transferred to the volumetric flask. So this will kind of increase the accuracy of the calculations which are done later on. Moving on, a different standard solution of ethane dioic acid was used to determine the concentration of sodium hydroxide solution J. Okay, so this is the procedure used. Now explain why the burette is rinsed with ethane dioic acid solution in step 2. First of all, to prevent the dilution of acid, or so that the burette so that the burette only contains the acid. So this is very much important. First of all, uh, so because if it's not rinsed, the acid, if it's not rinsed, burette might contain other than acid something else such as water, which we do not want, because this will kind of make, if water molecules are present, this will kind of make the acid diluted, but that's not the thing that we want, right? Because if the acid becomes diluted, the whole accuracy of the reaction will decrease. That is why this is very much important. The student then completely emptied the pipette for each transfer in step 3. Now explain the effect on the titer of completely emptying the pipette rather than leaving a small amount of solution in the tip. Now there will be more sodium hydroxide than expected in the conical flask, so the value of titer will increase. This is very much important because in step 3 it was done, uh, the completely emptying the tank rather than leaving a small amount, because there will be more sodium hydroxide left in the conical flask. So if something is left, the value of titer will increase. Okay, state the color change in the conical flask to the endpoint. Now, since phenolphthalein is used, it's going to turn from pink to colorless, considering the alkali is basically added dropwise. So obviously, when the acid becomes neutralized and turns into alkaline, when the alkali becomes neutralized and turns to acidic conditions, so it in under acidic conditions, the phenolphthalein shows colorless as color. Now the question is about the thermal decomposition of group 2 carbonates. The student basically heated a sample of group 2 carbonate down here until no more gas was produced, and the equation for the decomposition is shown down here. Now give a reason why the delivery tube must be removed from the water tube before removing the test tube from the heat source. Now this will prevent the suck back of the water. This is very much important, because if the water is sucked back, basically if the water flows back into the tube, then we will see the gas being produced. What's going to happen, the gas being collected or produced will be less, so that is why it's going to hamper the calculations which we need to do later on. So this is very much important, that the delivery tube gets removed before the water, must be removed from the water, but before the test tube is removed from the heat source. All right. The students suggested the experiment could be made more accurate by increasing the mass of carbonate from 0.33 gram to 1.00 gram. So no changes in the size of the apparatus or the method of the measurement of the gas produced could be made. Comment on this suggestion. Now remember, as I said, these type of questions are very much common, and we have seen this. Is that if we can increase the mass, it will reduce the percentage uncertainty, because the volume of the gas given off would be greater, and if the measured value of the gas is greater, automatically the percentage uncertainty gets reduced. So this is nothing new. The next question here: halogenalkane 2-chloro-2-methyl propene may be prepared from 2-methyl propan-2. So the procedure is provided. Again, the question is about the hazardous symbols provided, but this time they told you to suggest 2 precautions related to these hazard symbols. So for this, since it's corrosive and this indicates the the reaction is toxic in nature, so you can use gloves in order to protect your skin, and since it's toxic, you can perform the experiment in a fume cupboard. So these are the two safety precautions which are suitable enough for this answer. Now explain why the product in the organic layer in step 2 does not mix with the aqueous layer. This is because the product in the chloroalkane, which only has London forces and permanent dipole forces. We know something that like dissolves like, right? So obviously in step 2, which we have seen, the two distinct layer contains the required product is from a separating funnel. So the only viable option or the viable reason that comes in our mind is that due to not mixing is basically due to the difference in the intermolecular forces. So one has London and permanent dipole, while the chloroalkane has strong hydrogen bonding forces. So obviously, due to these differences, the chloroalkane cannot form hydrogen bonds with water, and that is why water is settles down at the bottom, while chloroalkane settles down at the top as the organic layer. Now, state why the tab of the separating funnel must be open in step 3. Again, the same thing, to relieve the pressure, to release the gas, to relieve the pressure basically, because pressure tends to build up during solvent extraction process, and it is highly important the tap is removed sometime. Again, the same thing, same question, same type of question again we have again encountered. Sodium sulfate acts as a drying agent, so nothing new in this one. We have seen this process of you know uh, drawing the apparatus of fractional distillation. It's nothing new, just ensure that a thermometer is provided. The main marking points is the correct directions of water out and water in, and obviously there shouldn't be any gap between the opening of the condenser and the round bottom flask, and obviously the thermometer as well, and the labelings must be obviously correct. Moving on, the chloroalkane produced is used in an experiment to compare its rate of hydrolysis with two other halogen alkanes. Explain how the results support this conclusion. So we are provided with the uh, you know the time taken for the precipitates being produced for each of the halogen alkane. So we can clearly see for 2-chloro-2-methyl propane it's the fastest. Why is that the case? Because this kind of this is a tertiary halogen alkane, while the other ones are primary. Now why is that the case? Basically because the CBr bond is kind of weaker. Obviously the CBr bond is kind of weaker than the CCl bond. Since the CBr bond is much more weak, why is that the case? Because CBr bond has a lower, the electronegativity difference is smaller, the polarization effect is smaller here compared to CCl bond. So obviously it's the bond breaking is kind of weaker compared to, the bond is kind of weaker compared to CCl bond. The CBr bond is easier to break. That is why compared to 1-chloro-2-methyl propane, 1-bromo-2-methyl propane tends to undergo a faster reaction, and that is why the precipitate is produced faster compared to 1-chloro-2-methyl propane. Now, to identify the cations in sodium chloride and potassium carbonate, a student carried out flame tests using the following method. Alright, so step 1, step 2, step 3, step 4. They said here, what are the improvements in the explanation for each of the steps for step 1 and step 2. For improvement, we can see a sample of solid sodium chloride placed on a watch glass. So instead of that, we can use a concentrated hydrochloric acid instead of a concentrated nitric acid. Why? Because metal chlorides are much more volatile in nature. So that is why since metal chlorides are much more volatile in nature, it's very much important that hydrochloric acid is used, because hydrochloric acid consists of the required chloride ions to produce the metal chlorides. Now, use of a loop of nichrome wire instead of copper, because nichrome wire is kind of copper produces blue green flame, but nichrome wire is unreactive, and it does not it kind of doesn't interfere with the results. So this is kind of very much important. Use the Bunsen burner with air hole open. This is very much important because they have said here in step 3 the with the air hole closed. Now the air hole must be open because the flame color will be much more easier to see through the opening of the air hole, and it will also allow the flame to be hotter, because if the flame is hotter, the color will be much more denser, and which will have a higher intensity, the flame color to be observed. Now, a student carried out an experiment to identify the metal M in the hydrated carbonate M2CF4.10H2, and this is the whole process with the equation provided. So the question was, the titration was repeated using an indicator. Describe how you would obtain a large dry crystals of the metal chloride MCl2 from this titration, and the diagrams are not required. First of all, you heat to evaporate the solution obtained to saturation, not to dryness. All right. You allow to leave to stand and allow it to cool down because the crystals are produced, and then you filter and dry the crystals, obviously, because the crystals might contain water. So that's the whole process of obtaining large dry crystals. So the second process is very much important to allow the crystal, the solution to cool down, so that more crystals are produced of higher amount and in larger shape. Moving on, bromoethane can be prepared by reacting ethanol with a mixture of sodium bromide and concentrated sulfuric acid. So explain why the sulfuric acid must be added slowly, because the reaction is exothermic, right? So adding slowly prevents the mixture from boiling over. So this is very much important. Because if the reaction is because since the reaction is exothermic, the products produced is volatile in nature. So that is why if we can add it slowly, then the reaction will take place at a slow, balanced manner. Moving on, we can clearly see step 4. The visual diagram of the apparatus used in step 4 is seen. So state 2 physical properties of bromoethane that can be deduced from this diagram. First of all, the density of bromoethane is greater than that of the aqueous layer. So obviously bromoethane is immiscible with water. So these are the 2 points, obviously. And another thing that you can say is that bromoethane is kind of liquid at room temperature. So uh, that's one thing. Due to the higher density, it tends to settle down at the bottom. And another thing is that since it's immiscible with water, the aqueous layer is basically water. So that is why these are the 2 main reasons basically that the components settle down like this in a separating funnel during solvent extraction process. And since it's a liquid at room temperature and the whole process is performed in under room temperature, that is why it kind of there is more suitability added for the bromoethane to produce in the to be produced as a liquid layer. Describe how the aqueous layer could be removed. All you can do is just open the tap and run off the bromoethane layer in a beaker, and you can just later on discard the aqueous layer to another part. After removing the aqueous layer, the sodium hydrogen carbonate solution is added to the impure bromoethane in a separating funnel, and the 2 layers are separated again. Now state why the sodium hydrogen carbonate solution is added to the impure bromoethane. Again, since it's in base itself, it's going to neutralize any sort of acids present, if there is any H plus obviously present. So it's going to again neutralize the acid. Now the bromoethane is placed in a sample bottle and the drying agent is added. Again, you can just give a suitable drying agent, it's nothing new. And the bromoethane is the organic layer is going to go clear when the water is basically is absorbed by the drying agent completely. Moving on, the apparatus shown was used to find the enthalpy change of combustion of one of the liquids, CD or E. So you need to list down all the measurements you would make in carrying out this experiment. So we have been provided the clue with a visual diagram here. So we can see water, spirit burner. So we need to we need to measure the mass of water, the initial and the final temperature of water, and obviously the mass of burner at the start and the end. So this is very much important because we need to use the MC delta formula to calculate the amount of energy used up. Other than changing the measuring instrument, in accuracy of the result using this apparatus could be improved. We can basically put a lid on the beaker to ensure, basically this will provide insulation, or it's going to act as a drought shield and reduce heat loss. And by reducing the heat loss instead of changing the measuring instrument will greatly increase the accuracy of the experiment. Again, the same type of question which we have encountered previously. All you have to do is draw the heat under reflux experiment, because the whole apparatus is performed there. So that's how you do it. Always tend to ensure that water out and water in, make sure that the directions are provided in the correct way. All right, and that wraps up the whole video. Hope this session helped you and you picked up some key insights along the way. If you found this useful, please like, drop your doubts in the comments, and share it with your study group. Don't forget to subscribe so you don't miss what's coming next. Stay focused, stay consistent, and let's crack this together. uh, we'll again meet onto a very exciting new video later on at the future. All right, bye bye people.